All right. So here we go. Bell 6. Circle the items below with axis symmetry. An axis is like a single line. And if I put it through one of these figures, will it look exactly the same from all sides? Okay. So who can give me one? Jewels? What? The vase. Yes, that is correct. The vase is going to have axis symmetry right here. It's going to look the same. How about another one? Is there another one? Jeremiah, what do you think? Axis symmetry, where it looks the same all the way around. The butterfly? Now, if that butterfly goes sideways, you see how the butterfly is like this, right? If this butterfly goes sideways, is that going to look the same?
Yeah.
Is it?
Yeah.
From this side? I mean, he's out here. If you look at him from the side.
Both sides, no matter what, even if it's fine.
Well, here and from the back, maybe, but what about the side?
I've seen the butterfly from the side. You never been outside when you was a little child, or been out since you was back then. Like,
But he's not going to look like this.
yes.
He's not going to look three-dimensional from the side. He's going to look skinny. So I don't think the butterfly is going to work for axis symmetry. Not for axis. For plane symmetry, yes. Not axis symmetry. Want to try again? The what?
The orange.
Yes, the orange. If you look at that from all sides, that has axis symmetry. Axis symmetry. What about this crocodile or alligator? I can't tell which one that is. No. If you look at it from the side, it is not going to look the same. Okay? Any questions on that? It's like it's on a pottery wheel. It has to look exactly the same from all sides as you turn it. Okay? All right, the second one. Which of the following, and it's kind of hard, I'm going to try and make it a little bigger. If we rotated these figures around that axis, which of those is going to look like the washer on the right?
Top right.
Top right? This one right here?
Yes.
Well, let's think about this. So if I take this and I rotate it around, how do I show that even? If I rotate it around, I think it's going to look like a sphere on the outside.
I'm looking in a circle.
Right. It's rotating around in a circle, but this top part, right, is going to go around. We won't see this hole because the outside layer is all the way there. So the hole is going to be on the inside. So it's going to be a sphere, which is a three-dimensional object with a whole sphere, a sphere that's a hole in the middle. Now this is definitely not a sphere. That's just a washer. So I don't think it's going to be that one. Anybody else? C? Let's see. Which one is C? Is there a C?
I don't think they're like.
I don't know.
Okay, here. Let's do this. 3. All right, let's take a look at this. So if I rotate that around, that's kind of like a very thin rectangle, right? If I rotate it around, you're right, it is going to be circular, but is there any hole in the middle? No. So there's no hole in the middle to show the hole in the middle of the washer. So I don't think it's going to be 3. Yes?
I'm confused. I'm so confused. Like, so I thought it was gonna look like that shape.
Over here?
Yeah.
Yes, but that's at an angle. It's a washer. Are you familiar with a washer?
Yeah.
Okay.
So are we turning it like this way?
We're not turning it. It would be as though it's being rotated like this. And maybe that's the way to do it. Draw that axis of symmetry in and down the middle, and then look at it from the side. Okay? What's that going to look like then? Which picture? Yeah, number 4. Because you're going to see a little bit of the side of that, and then you're going to see a hole, right? So that is number 4. Okay? That is rotating it to make a solid of revolution. Does that make a little more sense now, Daniel? A little bit? Okay. All right. Okay, let's turn now to page 25 of your notes. We're talking about volume, no longer talking about surface area. Going to volume. 25. So 6.6, we have this one, this section that we'll talk about today and tomorrow. We have 6.7 that we're going to talk about Wednesday and Thursday, and then we start reviewing. We're going to review on Friday, we're going to review on Monday, and then you have a test over surface area and volume next Tuesday, a week from this Tuesday. Okay? A week from Tuesday. All right, here we go. Volume. We're talking today about volume of prisms. What makes a prism a prism?
3D.
Okay, it's 3-dimensional. What else? There's a little bit more than that. Say it again. A square. A little bit more. Can you say more? Okay. How many bases does a prism have?
1.
2. Has 2 bases, a top and the bottom, that look exactly the same. Okay, that is really important for a prism. 2 bases that look exactly the same. 3-dimensional, 2 bases, and I think that's probably it. That's talking about a prism, okay? All right, it says, recall that the volume of a solid is the measure of the amount of space this solid encloses. And we are talking about now, instead of how many squares it holds, how many cubes, okay? How many cubes can this prism hold? And they're measured up side by side. All right. Volume is measured in cubic units. So I want you to square or underline that. Cubic units. This rectangular prism has 6 times 4, or 24 units on the bottom layer. So it's 6 this way because there are 6. 1, 2, 3, 4, 5, 6. And 4 this way. 1, 2, 3, 4. Because there are 2 layers then, it's 24, which we got from 6 times 4 is 24, times 2, which is 48 cubic units. Yes?
Are we on this page or are we on a different page?
I think we're on 25. Is it 25?
Yeah.
So it should be 25.
So we're on the top? Mine's different.
What page is that? Right there.
17 up 24.
24. I guess it's 24. Sorry.
Oh, okay.
24.
Thank you.
Uh-huh. Thanks for bringing that to my attention. Okay, the volume, going down here, volume of a prism is base times height. So make that really big somewhere. the area of your base, times the height of the figure, times height. Okay? So area of the base times height. Base is your bottom, and that capital B means the area of the base. Whatever that base might be. In this case, it's a rectangle. Could be a triangular prism where the base would be in the shape of a triangle. Yes?
Can you zoom
Huh?
out? Can you zoom out?
Zoom out, zoom like this?
Like, second together.
Okay.
Thank you.
Okay. And it says, following that, if two solids have the same height and the same cross-sectional area B at every level, then they have the same volume. So, looking at this, you can have your base down here, and as long as that whole figure has that same shape, we find the perpendicular height has to be straight up and down height. We can still have the same volume. So over here, I have my base in green. I still am carrying that base all the way through though. It's still that same shape. It's kind of like if I had a rectangular slinky, okay? I can shift it over, but it's still going to be the same volume, whether it's upright or whether I kind of shift it over to the right. Okay? All right. Two solids have the same height and the same cross-sectional area. So then down here, notice this is a different sized base. But let's say this was like 3 by 8. Okay, let's say this one was, I'm doing this off the fly, so it's not great, 4 by 6. And let's say this one was, I don't know, 2 by 12. So all have the same area of the base. All have the same area of the base, which is 24. And then as long as my height is the same, let's say this is 5, this height is 5, this height is 5, with the same height, gives the same volume. Okay? So as long as your base is the same, here, 3 times 8 is 24. 4 times 6, 24. 2 times 12, 24. And then you take times that perpendicular height, you're going to get the same volume for each of those. Any questions about that? Yeah. Yes. All right, let's go to example 1. Finding the volume of a prism. Says find the area of the base. The base is the bottom. What is the shape of my base here? A rectangle. So you're going to take length times width. Let's put the phone away, please. Length times width. So volume equals capital B times H. Area of the base times the height. Your base is a rectangle. So that is length times width times the height. Length is 12. Width is 3. So the area of the base is 36 feet squared. Bjorn, come on back. All right, so the bottom here, this is what is 36 feet squared, okay? Then to find the volume, volume is area of the base times the height. We just found what our base was, so substitute that in, 36 times, what's the perpendicular height of this rectangular prism? 8. So multiply times 8. And I don't know what that is. Looks like 288. Check my math. 288 feet. And here's what we do for volume. Because we're finding cubes, it's going to be feet cubed. Feet cubed. Yes. Huh? I don't have the notes up on Canvas yet for this one.
Are you posting later so I can go back to that part?
Yep, that's the intention.
Yeah, I'll do that.
All right, so let's do the check on this one. The check is going to be similar, but this is a different shape. Now remember, if it is a triangular prism, the triangle part tells you that that is its base. You can only have two bases. So if you look at this, I want you to shade the triangle part. Okay? So this is a triangular prism. If you look at all the other sides, they're going to be rectangles. So that means I have to calculate the bottom first. So volume equals the area of the base times the height. All right, and we're going to focus on the area of the base first. So for a triangle, does anybody recall what the area of a triangle is? The formula for an area of a triangle? It is, I don't know if that's on there or not. I probably look for a volume of a, that's very specific though. I don't think it is. It's going to be 1/2 times the base of the triangle times the height of the triangle. Okay. This is just the base that we're finding right here. So 1/2 times base times height of the triangle. All right, so we got 1/2. The base of my triangle was right here, like what it's sitting on. So that's 9 times the perpendicular height. Okay, your height is right here. That's the height of the triangle. Do we have that length in green? Do we have that length in green? We do not. We have this in blue, which is 15 feet. We have this, which is 10, but we do not have that height. Good morning. Okay, so guess what we're going to have to use since we have a right triangle? gonna have to use Pythagorean theorem. Pythagorean theorem. So a squared plus b squared equals c squared. The two legs are going to be my a and my b. So I'm going to make 9 my a. I'm going to make b this height that I need to find. And c is going to be the hypotenuse, the side across from this angle. Okay, guys, I really need you to look at this. People are still having a lot of difficulty with the Pythagorean theorem. So my a value is 9. Substitute 9 in there. My b value is what I'm looking for, so I don't have that value. I'm going to leave it as b. And c, the opposite side, is what's here in blue, 15. 26. We're on 26. So 9 squared is 81 plus b squared equals 15. Oh, I forgot to square that. 15 squared is 225. Since I want to get b squared by itself, I need to subtract 81 from both sides, and I get b squared equals 144. But I don't want b squared, I just want this length of b. So take the square root, and I get b is equal to 12. So that means the height of my triangle is 12. Okay? So this is all being multiplied. So in my head, I'm just going to take half of 12 because 12 is even. Half of 12 is 6. And then 6 times 9 is 54 feet squared. That is just the base of my triangle. Okay? That is just the base. That's just one base. Well, if you look up at the top, it says volume is the area of the base times the height of the prism. Okay, so right here is the area of my base, 54. I'm going to substitute that in. Times the height of my prism. Well, if I were to take that triangular prism and lay it on its base, its height right here is 10. It is 10 feet tall. So times 10 gives me 540. My units are feet cubed. So volume is 540 feet cubed. You are going to have a triangular prism in your homework tonight, so make sure you get all of that down.
How come you use texture as well?
Do I have a rectangular prism up here? I do not. It's all in the way that your triangular prism is done. So that's a great question. Great question. Since I'm trying to draw this. I am not the best artist here. But this is my base, okay? Something like that. This is my base. And I found the area of that. So the area of my base, volume equals area of the base times the height. And here, this was 12 feet. This was 12 feet, but it's on its side. You see how the base is, I'm sitting on the base here, but in the picture, your base is on the side. So my height, the height of this prism was actually 10. We're not talking about the height of the triangle. We're talking about the height of the prism. Does that kind of make sense? So this was laying on its side in the picture here. So this was 12. Let's see. This was 9. This is 9. And this is 15. This is 15. Does that kind of help and make sense? That it's on its side. So in our picture, looking at it from a slightly different angle, so this was 9 feet here. This was my B, which I was trying to find. There's 10 feet, there's 15. Okay, so this is the same thing, only it's turned. And you have to talk about the height of the prism, not the height of your triangle. Does that make sense? There are two different heights. Height of your triangle, and then the height of the whole prism. Okay? Great question. Great question. Okay, let's go to the next one. If I can get to the next one. Okay, volume of an oblique prism. This is kind of like that slinky that I was talking about. So, volume of an oblique prism just means it's slanted. Find the area of the base. Well, take a look at your base. The base is the area of the bottom. What shape is that? No, but it's not a square. It's not the same on all sides, is it? No. What you have to remember, a rhombus has all sides that are the same length, is that this is angled. Maybe, I think because it's angled in the picture, I think it's probably a rectangle. It could be a parallelogram. Could be a parallelogram. It's kind of hard to tell, but it's the area of that base. And for a rectangle, it's length times width. And for a parallelogram, it's base times your height. So they're both essentially the same thing. Okay, so the area of the base, which is a rectangle or parallelogram, is going to be length times your width. So that is essentially 2 times 4, which is 8 centimeters squared. Because you're talking about area right there. The volume then, volume is equal to the area of that base times its height. Area of the base, here's my 8. Substitute that in for your capital B. Times your perpendicular height. We don't want our slant height. We don't want that. Has to be perpendicular. So times 16 is equal to 128 centimeters cubed. That is your volume. Okay. And they did not tell us what it says just the oblique prism. Okay. Down at the check, I'm not going to do this one totally with you, but it calls it a rectangular prism. So you would find the area of your base times your height. Okay? Area of the base times your height. So this is a rectangle. and then times your height. All right, and I'll have those in the notes a little bit later. Questions on the top one, example 2. Any questions on that? Hey, guess what? We are done with notes for today. All right, so homework. We just don't let up with homework, do we? You got to practice, though. Homework, and I am going to pass this out to you. I am changing it up. We are not doing the whole front side. I'm changing this up to be, because we haven't gone over everything yet, problems 1, 2, and 3 on the front. And on the back, 22 and 24. A simple block. 22 and 24. Okay, so let me pass this out because you do not have this one yet. So 1, 2, 3, 22, and 24 for this one. 1, 2, 3, go. All right, so I'm going to try to help you very quickly with number 3 of this homework. Guys, put the phones away, please. Come on. Huh?
So we're still taking that look.
Taking down notes? We're done with it today.
So we're still taking.
Oh. All right, so let me do number 3 with you because that's that triangular prism. Oh shoot, I didn't want to get rid of that. And I don't know if I have that one. What is this? 6.6. All right, I gotta upload it really quickly. Oh my gosh, they want me to show my password. They're lucky I even remember it today. How do I get that? Go. Oh, they didn't like that. Great. Okay. You guys like me where you just get tired of putting in your passwords all the time? Oh, I hate that.
You got the fingerprint thing?
No, I don't. Does that work pretty well?
Yeah, it does.
6.6, here we go. Import. 30 seconds remaining.
Or 30 seconds.
You guys probably could have done the first problem by now. Number 1, the volume, area of the base times the height. Yeah, that one's pretty. 1 and 2 are not bad at all.
Then volume Q.
Yes. All right, make sure to show all work to solve the problem. So just a reminder, you need to do problems 1, 2, 3, 22, and 24. Not just the front part, because we haven't done all the front part. All right, and I am helping you with number 3. Number 3. All right, so volume is area of the base times the height. Guys, head up. Come on. Let's go. Jeremiah. Jesus, heads up. So in this figure, this is a triangular prism. Triangular prism. It has 2 bases, and they are facing us. Okay? They are facing us. So this base here is a triangle times the height of the prism. All right? This triangle is 1/2 times the base of the triangle times the height of the triangle times the height of the prism. So let's focus on just this triangle right here, because that's what we're looking at for our base. So it's 1/2 times the base. Do I have that base length? I do not. This in blue. So we have to find that times the height of my triangle, 5. But I do see that this is a right triangle, so I can use, again, Pythagorean theorem to find this opposite side, okay? I'm going to have this side be A. Let me do it in
Can you
the
read that one? The one right there, next to A, B?
5
No, the TH, what's that?
triangle. I don't know what you're talking about.
Pythagorean. Oh, that's what you were trying to do, Pythagorean theorem. You was about a dot right there. Like,
Yeah, Pythagorean theorem.
I mean, like that right one. What does that say right there? Like on the right side of the word.
Theorem, THM.
TH, I think.
So this is A, this is B, and this is going to be C. So my A, I don't have. A squared plus B squared equals C squared. A, I don't have. B is 5. And C, which is this length right here, I wanted that in green, is going to be 13 squared. So A squared plus 5 squared is 25 equals 13 squared, which is, thank you, I was thinking that, but I wasn't absolutely sure. I want to solve for A squared right now. So subtract 25 from both sides to isolate the A squared. And I get A squared equals 144. But I don't want A squared, so I take the square root, and A is equal to 12. So A, in my triangle, that length of the base is 12. So I get 1/2 times a base of 12 times 5. Half of 12 is 6, and 6 times 5 is 30 meters squared. That is just the base. Now, the height of my prism is right here because the base is facing us. This is like a wedge of cheese where the bottom of the cheese is facing us. So the height is 3 meters. Volume equals area of the base times height. Substitute that 30 in. So 30 times a height of 3 is going to be 90 meters cubed. $90 meters cubed. Okay? So you have 4 more problems, 1 and 2 on the front, 22 and 24 on the back. Please do that for your homework tonight. Does anybody have any homework to turn in to me?